Hello, calculus. Welcome to more on particle motion. This is your next set of notes. So we're going to start looking at finding net and total distance. So think about this. We've got a horizontally moving particle, so we're moving just left or right. This graph below, be careful, it's representing the velocity measured in meters per second. So this is not a position graph, this is our velocity graph of a particle moving just along the x-axis. At what values of t does the particle have no acceleration on the interval from 0 to 10? So between 0 and 10, when is my acceleration 0? No acceleration, right? So my acceleration is going to be 0 when my derivative of my velocity graph is not differentiable. So I would say A of t is undefined. What does that mean? It means the derivative of my velocity graph is undefined. That's when the derivative of my velocity graph doesn't exist. So if this is my velocity graph, when can I not differentiate this graph? That's going to be when we have a sharp cusp, right? So up here, I have a sharp point down here, I have a sharp point here, and a sharp point here. So those are the 4 places where we are not going to be able to differentiate that velocity function, which means my acceleration is undefined. So we're undefined when v of t is not differentiable. Not differentiable just means we can't find the derivative, and again, we can't find the derivative when we have a cusp. So since v of t has a cusp, what does a cusp mean again? That's just a sharp point, right? Has a cusp at t equals 1, 3, 6, and 8 seconds. There is no acceleration at these times. Lots of writing in calculus, huh? Not as much as statistics from what I hear. All right, express the acceleration A of t as a piecewise defined function. So remember, A of t is the first derivative of our velocity. What is a derivative? That's the slope of the tangent line. We've got a nice piecewise defined function here because we've got 1, 2, 3, 4, 5 straight lines. If I want to find the slope of the tangent function on these lines, it's going to be the slope of those lines. So this isn't going to be that bad, but there are 5 pieces to it. So for my acceleration function, let's find the first slope. This guy is going up 3 over 1. So the slope of that tangent line is going to be 3, and that's between t equals 0 and t equals 1. There we go. All right, what about for our next segment? We've got between 1 and 3. Our slope looks like it's down 3 over 1, right? Down 3 over 1. So my slope is going to be -3. Remember, slope of my line, that's the derivative. First derivative of velocity is my acceleration. So slope is -3. That's between 1 and 3 seconds. All right, between 3 seconds and 6 seconds, what's the slope of this piece of the line? 0, right? We have a horizontal line. So between 3 and 6, we're at 0. Now we need to find the slope of this piece. Again, we're going up 3 over 1, up 3 over 1, so it's going to be back to positive 3. Between, 6 and 8 seconds. And then finally, we're going down 3, but this time we're going over 2. So down 3 halves, -3 halves, and that's between 8 and 10. Between 8 and 10 seconds. All right, for what value of t is the particle moving to the right? So remember, our particle is moving to the right when the velocity is what? When our velocity is positive. When is our velocity positive? when we are above the x-axis on our graph here. So my velocity has a positive value between 0 and 2 and between 7 and 10. So the particle is moving to the right. When velocity is greater than 0, which occurs between 0 and 2 and 7 and 10. All right? Look at that graph. Tell me when is that particle going to be moving to the left? So particle is moving to the left when v of t is less than 0, when my velocity is negative. That's when my graph is beneath the x-axis, so we're negative down here. My y values are negative down here, so that's between 2 and 7. So which occurs between 2 and 7. All right, and finally, it asks us to find the average acceleration of the particle in the interval 1-8. So our average acceleration is going to be V1 minus V8 all over 1 minus 8. So looking at our graph here, my y value at 1 is 3. My y value at 8 is also 3. So this is going to be 3 minus 3 over negative 7. That's 0 over negative 7, which is 0. So our average velocity is going to be 0 meters per second squared. Does that mean we didn't move at all or accelerate at all during that time? No, that just means that our average velocity between 1 and 8 is 0. So overall, it averages out to 0. All right, when I come back, we'll finish this last piece and we'll move on to the next page where we start talking about net difference and total distance.